Okay. Tebo.
Evening.
Good evening.
Good evening.
The stage is yours, my brother. Please show us how you can dance by sharing an answer to number 5 with us.
I believe I got the square root of 3 over the square root of 2 for number 5, if I'm not mistaken. I can't remember which exam pad I wrote it in, but I do know it's the square root of 3 over the square root of 2.
And let me write. Deborah, you're saying the answer is?
The square root of 3 over the square root of 2.
Square root of 3 over the square root of 2. Okay. I'll come back to you. What?
I got square root of 3.
Yes, I got negative square root of 3.
Oh yeah, it's
Negative
negative. Yeah.
square root of 3. Okay. Next one.
Yes.
Three people have got different. 3 people have got 3 different answers for the
No,
same exercise.
I forgot
This is
negative.
interesting.
So I forgot negative.
Who forgot negative?
Come well.
Kamore. Okay.
Yes, I
Now,
forgot the negative.
okay. Now, if we put the negative there, then out of 3 people, 2 people have got the same answer. One has, okay, out of 3, 2 people have got the same answer, and then 1 person has got a very distinct answer. Next one, Lerato, the last one.
So I don't think there's anyone else who was here yesterday that's also here today.
Hello. Yes,
Unless
Mandla
I'm
here.
mistaken.
Oh yeah, Sumani.
Yeah, Sumani here. I was here yesterday, so I also got negative square root of 3 because of the quadrant. The answer is in. Yeah.
Okay,
Your
sorry for
name,
not remembering.
your name, sir?
Sumani, surname Mandla.
Oh, Mandla. Okay.
Yes.
Mandla, negative root 3.
Yes.
Okay. Let me reserve my comment for now. Now, let me go to the chairperson. Chairperson, what did you get, my sister?
I also got negative root 3.
Okay. Chairperson, now I'm requesting you to go to Tebo to explain to us how we arrived at square root of 3 over the square root of 2.
Tebogo, the floor is yours. Please, can you walk us through your step-by-step process, how you got your answer?
Yes, I do realize I made a mistake. Okay, I can explain the question, but I do realize the mistake I made in my calculations.
Okay, so just explain it and then show where you made your correction and where you made your mistake, if that makes sense.
All right. Okay. All right. We have this is number 5, where we have the limit of 10 5 pi over x as x approaches 3.
Yes.
So I initially changed I changed pi. I mean, I changed 10 into sine theta over cos theta, and then I then said it's 3 pi, and then I substituted because it's not undefined if I substitute the x for 3. So then I substituted that so that I could have 5 pi over 3. So it's sine 5 pi over 3 over cos 5 pi over 3, and then I separated the 5 pi over 3 into 2 angles. So it was 3 pi over 3 plus 2 pi over 3. And then from there I applied the is it a double angle rule? And then I had the square root of 3 over 2, yeah, negative, because it's 0, it's on top, it's going to be sine pi cos 2 pi over 3, and where sine pi is equal to 0, so it's 0 times cos 2 pi over 3, which is equal to 0, plus cos 2 pi over 3, no, cos pi sine 2 pi over 3, which is cos pi is -1, and then sine 2 pi over 3 is what did I write? The square root of 3 over 2. So then I have the square root of 3 over 2 in the numerator, and then in the denominator, I know sine pi is 0, so because it's a double angle, it was just going to be cos pi times cos 2 pi over 3, which is equals to -1. And then I put, because I was using my head, I said, this is where I made the mistake. And then I said times the square root of 2 over 2 instead of a half. So that's where I got lost. And then I realized, no, man, I see where I had my discourse. So cos 2 pi over 3 is in actual fact 1 over 2. So, and then it's negative 1 over 2, and then and times -1, which is positive, and then so, and then it's 3 over square root of 3 over 2 divided by a half, and then the 2's cancel when I flip it over and I multiply, and then I came back to the square root of 3. That was my explanation.
Members,
Yes, sir.
Yes, sir.
did we all hear the explanation provided by our brother Tebo?
Yes, sir.
Yes, sir.
Okay. Chairperson, Kamarelo, problem solver, and Mr. Mandla. Amongst the four of you, who volunteers to actually help out Mandla to get to minus the square root of 3?
Sorry, so you're saying I must explain how I got to that, or should I choose someone to explain on my behalf?
No, what I'm saying amongst Kamarelo, problem solver, Mandla, and the chairperson, whoever feels like volunteering, please do so to explain to Tebo how we arrived at negative the square root of 3, which is an answer to this question. Anyone?
I can explain, sir.
Anyone? Whoever? Okay, let's say for now, may we please then give Mr. Mandla a chance. If Tebo doesn't understand Lerato, then you can follow. Is it okay?
Sir. Yes,
All
sir.
right. Thanks. Mr. Mandla?
Yeah, okay. I'm currently walking to the Uber, but I'll try and open my book, yeah? So the way I understand how these things work, right? So I took the 5 and I
Mr.
put it on
Mandla?
the side. Yes, am I audible?
Yes, very clear.
Yes.
Okay. Hang on, my brother. Please call Tebo and ask him to listen attentively.
All right. Tebo, how are you there?
I am here. I'm here.
Okay.
Oh, all right. Yeah, let me see. Apologies, can someone else explain? I'm walking to an Uber, right? So I can't open the book, but I'll explain the next one. Sorry about that.
No problem. Lerato,
Yes, sir.
please take over my system by explaining to Deborah.
Okay. So I think the methods we all used was similar to the one that Mandla was about to explain. So he was basically saying he took the angle of 5 pi x, which is in radians, and he changed, oh, this is what I did. I changed it then into degrees. But first I substituted in the threes. So I have tan 5 pi over 3, and then I multiplied the angle by 180 degrees over pi, and then what I was left with was 300 degrees. So tan 300 degrees, and then I used the reduction formulas. So I then had tan 360 degrees minus 60 degrees, and then in the fourth quadrant, tan is negative, so I put a negative tan 60 degrees, and then I evaluate that tan 60 degrees, which gives me the negative root 3.
I agree with you.
And the
Deborah,
reason I just wanted to say, Tebogo, because he used a different method, but he still got to the same answer. And then the method we used is the one that we did in, I think, sir, you explained it in one of the previous workshops. So when he was explaining his method, I didn't fully follow, but there has to be like, it's probably right, like just an alternative method to getting the same answer.
I don't know, maybe I imagine I came to the same answer as everybody. I was gonna write it properly. I imagine I came, but then maybe in my rambling, it wasn't concise as to what I did. But if, okay, may I ask, the initial step to change tan into its sine over cos, is that a long way round of doing it?
I would say yes, because it's not, we don't need to change it into sine over cos because we can evaluate it as tan.
Oh,
And
okay.
with the
And
double
then,
angles and that you used, I don't use the double angles. I'm not sure where they come up, but
my reception is poor. I beg your pardon. I lost audio for a second. Maybe somebody.
you were wanting to say something about, I'm not sure.
Okay. Yes. No. Another thing. The reason I changed it, is so that I can, because I don't know direct. Because I know a circle is 2 pi. So, and then I know halfway through the circle, a semicircle is pi, and I know on the other side, cos is -1, and then sine is the x-axis is going to be 0. So that's how I know. And then pi over 2 is at a 90 degree. So pi over 2 is a quarter of the circle. Hence, I prefer to use radians. I found them to be slightly easier. But then hence I changed my angle from 5 over 3 pi to 2 angles. But then I do realize I could have said 2 pi minus because this is precisely the same as pi over 3, if I'm not mistaken. This angle in the opposite.
The angle of 5 pi over 3. Is that the
Yes.
angle you're referring to?
Yes, it's say 5 pi over 3 is equals to it's 2 pi minus 1 over 3 pi.
I'm not well versed with the radians
say
and working with them, which is why I don't use them. And in the previous examples that Sir worked through with us, he had encouraged us to change the angles where we can to degrees.
Okay.
That's why we were changing them in the beginning. And then working
Okay.
with reduction formulas from there.
All right. Okay, I do see. But I do see. But I believe this entire thing resets after 2 pi. So if, say, I have 2 pi minus pi over 3, then I just have the negative. I can omit the 2 pi as opposed to what I did using 2 pi over 3. I can omit the 2 pi because it's redundant. It has reset. And then I use the negative pi over. Well, I'm still going with my with my radians, but then
Yeah. Okay,
Because
yeah, I get what you're trying to say though.
yeah.
Because it would be a full revolution at
So
that point.
oh yes.
Lebo,
Okay, let me just write it properly. Then hello,
Lebo,
doctor. Very good evening, sir.
good evening.
Yes, sir. Good day.
You are
Doctor.
confusing the chairperson and myself. I can feel that the chairperson is confused. And so do I. And
And I
so
am-
do I. Sorry?
Okay.
I'm confused,
My
sir.
Yes, I can feel that.
okay. May I explain myself maybe like to you exactly what I'm trying to say, like so you can understand what I'm seeing.
Okay, please do so, my brother, slowly so that we can be able to follow in such a way that we can be able to get where you are losing it so that we can be able to come in and help you.
Okay, yes. Okay. I have my angle where I was trying to explain to you. Because we have an identity that says sine negative theta is equals to negative sine theta, right? So from there, because I have 5 over 3 pi, which is the same as 6 over 3 pi minus pi over 3 minus 1 pi over 3. And 6 over 3 pi is the same as 2 pi, and I can omit that because that is one revolution. It resets, so I can omit it and say it's sine negative pi over 3 over cos negative pi over 3. I don't know if what I'm saying is making sense. And
Wait,
then I would
when you after you said 6 pi over 3, was it minus 2 pi that you
no. I have 5 over 3 pi, right? Which is the same
Okay,
as
yeah.
6 over 3 pi minus 1 over 3 pi. So 6 minus 1 is 5. But 6 over 3 is equals to 2. And 2 pi, if 2 pi is a full revolution of a circle, because I was using a circle, I wasn't using like it's a period of a cosine graph or a sine graph, it resets. So that's redundant. So I omit it. And then I say that was one single revolution. And then I just have negative pi over 3, which is negative 1 over 3 pi. So I have sine negative pi over 3 over cos negative pi over 3, which is negative sine pi over 3 over cos pi over 3, if I am not mistaken. Yes. Which comes to, because negative pi over 3 is in the fourth quadrant, and then for cos it's going to be positive, nah? Because it will still be on the right. So it's going to be negative. I beg, yes. So it's going to be negative the square root of 3 over 2 times times 2, basically, or divided by 1 over 2, which becomes negative square root of 3 over 2 times 2 over 1, and then the 2's cancel, and then it's negative the square root of 3 over 1.
Which is?
Sir, please, I'm trying to justify myself. If I may be ignorant.
Negative root 3 over 1 is the same as negative root 3. Do we agree?
Yes, sir.
Negative root
Yes,
3
sir.
over 1. Negative root 3 over 1 is the same as negative root 3. Do we agree?
Yes, sir. Yes, sir. We agree.
Please let me say this. From where I'm sitting, I'm not saying what I actually shared with you earlier is the only way to approach this. But whichever way that you are approaching these exercises, different from the way that I shared with you, you and I will have a problem once we don't get the same answer. I'm not saying follow the way I've shared with you on how to approach these exercises. One approach that at the end, you and I must get the same answer. Then that's where the problem lies. I don't know whether we are together there. Let me be honest. I'm still confused.
I can't hear.
So you're kind of cutting in and out.
Oh yes, I thought it's me. I also can't hear. I didn't catch what sir had said there.
Yeah, at the end, but
am I breaking?
yes, slightly, sir.
Okay, please change to this network if that is the case. In a few seconds, and let me go to
Tebogo,
Hello.
did you hear the part, the first part of what sir was saying?
No, I didn't catch anything. I had moved my phone on. I was holding my phone, so I didn't catch. All I heard was just to give me. All I heard was we shouldn't get different answers despite us using different methods to get to the answer. If we use different, if our answers are different, we have a problem or something like that.
Yeah, because I was also thinking you're using radians, which is what you're more comfortable working with. I don't like radians personally, but if you can work with them and we get the same answer, it's fine. So it wasn't that you didn't understand necessarily how to answer the question or how to do the question. You just used a different method to us. But you still arrived at the same answer, which means it's fine.
Okay, thank you. So I'm off the hook, people.
Yeah, you were never really on the hook, so to say. Your method is sound. Maybe not to us, but we arrive at the same answer, so it's fine.
I know, I appreciate that.
Am I audible now?
Yes.
Yes, you are audible, sir. Thank
okay.
you. Thanks a lot. Sorry.
I switched off from that other one. Now, this is what I was saying. Deborah,
Oh, sir, I
after you are...
was just explaining what you said, sir. Because I caught
Oh,
what
okay.
you were saying, but then he didn't catch the last part of what you're saying, which
Mm.
but you were basically saying, sir, our methods can be different, but we must arrive at the same answers. So
Yes.
you and I used the way of using the angles with degrees, and he used radians, which he's more comfortable with. But as long as we arrive at the same answer, it's fine. And then because we arrive at the same answers, it means both of our methods are sound mathematically.
Mhm.
So we're together,
So-
sir. We can proceed to the next question.
Okay, thank you. Now, may we then proceed to that was number 7, number 5.
That
no?
was number 5.
Still the first
Number
one.
5.
Hey.
Yo. Yeah. Okay. Number 7. At the beginning, remember I had 2 people. Lerato, I think it was you and who?
And me.
You, Kamrelo, ne?
Yes, fine.
Okay. Chairperson, please, you can now have a sip of water from that glass of yours. Let's request Camarello to take over the hot seat.
Thank you, sir.
Thank you, my sister. Camarello, we are in your good hands, in your capable good hands. Safe hands.
Let's hope so.
Please, 3 people. Choose 3 people to share their answers to number 7.
Those who were here yesterday, right?
Those who were here yesterday, my brother. Yes.
All right. So,
Particularly those who tend to hide.
I do was here yesterday.
Sorry?
Nigga, I do nalumu
Adiva, abare emlo. Is he here? Adiva. Samuel, is Adiva here?
Yes.
She's here, but I don't think she was
She's
here
here.
yesterday.
Okay.
Okay.
There's at least
Now
five
let-
of us who were here yesterday.
Okay, Lerato, give us your answer then.
I was just trying to help.
Nah, give us your answer.
Next time I'll be quiet then. Which one, number 7?
number
Yes, number
7,
7.
yes.
I got 4.
Okay, Togo.
I also got 4.
All right. Shomani.
Yeah, none and 40. So just to explain, because I didn't explain the other one. So I directly substituted. So it says lim x approaches pi over 3. So I substituted that for x. And then we know that cos pi over 3 is equal to half, right? But there's a 2 before the cos pi over 3. So I multiplied by 2. That became 1. 7 plus 1 to the power 2 is 64. And the cube root of 64 is 4. So in the itangoraro or in the 1.
Nice one. Nice one.
Rolly Wangamanda.
Nice one.
Who else? The last one. Oh, the chairperson himself. Chairperson, what did you get?
So I got 4, sir.
You got 4.
Yes, sir.
Thank you, family members. We are in agreement. Mr. Mandla has already explained how we arrived at 4. Is there anyone who doesn't understand how we arrived at 4? Anyone who doesn't understand? Okay. Now, let me thank the outgoing chairperson to appoint the next chairperson.
Yeah, the next chairperson should be double.
Double. Double. Double.
Forgive me, I was trying to get my microphone. I have to put my phone in a place of where there's network. Sorry.
No problem, my brother.
Okay.
Yes.
Double.
Okay.
The next
I'm-
one is number 9. Ne?
Okay.
Now I'm requesting you to get 3 people to share their answers to question number 9.
Okay. May I just scroll here in the attendees? Sorry. Okay, I saw Mr. Renz, is it? Sorry, please forgive me. Please don't, let's come better. Renz
No,
Shaba.
they won't. You are protected. Don't worry. We don't fight here. We don't fight. As long as you tried your best to pronounce someone's name or surname, then that person will come in and rectify us.
Okay.
Yes.
Sorry, Renz Shabangu. I'm not quite sure. I don't know if you are present. May you please? And then also, I'm not
one
sure
at a
if
time, Deborah, one at a time. Oh, yes, one at a time. Yeah. You call that person, then that person shares the answer, then we move on to the next one, then we move on to the third one. That's how it goes.
Okay.
Please call the first person.
Renz Shawangu, are you here?
Hello. Hi.
Mr. Shabangu, how are you?
Mr. Shabangu Naseo.
Yeah, excellent.
Oh, my apologies.
It is actually Shabangu. Apologies, guys. I'm babysitting and making noise with kids here. So, which question are we on?
Number 9. We're looking for an answer to number 9.
Number 9.
The baby can also help you to give you an answer. Just ask the baby.
I'm thinking of doing that.
No, more than welcome.
Let me go through my pages. Number 9, you said, hey? I got
Yes,
2. Number 9 is 2.
2.
Okay.
Yeah, you said your surname is Shabangu.
Shabangu, yes.
Okay, I captured that. Deborah, please go to the next one.
Lebohang Ledwaba. Lebohang Ledwaba.
Hey, Lebohang.
Hello, am I audible? Hello?
Yes, you are.
You're audible.
Okay. Yes, I chosen Lebohang Ledwaba.
Lebohang.
It's quiet, Lebohang.
Hey, Lebohang. Hey, Lebohang, you are not in a movie. We are in a workshop. Lebohang. Oh, probably Lebohang that he or she thinks she's in the movie while she's not. We are in a workshop here. We are participating. We are working. Deborah, please go to the next one.
Okay, Mr. Ralph Mr. Ralph, the only person that's unless Maluleka is also Ralph.
Mr. Ralph, is it Buotas or Buota? Deborah, what is the same? Is it
yes, keep Buotas. Yeah,
Good boats. Your name, Maramona Ralph. Good boats.
Oh, Ralph.
Ralph, can you give the answer? Yes.
Ralph.
Also quiet.
Ralph.
Guys.
Ralph.
Oh, Adivao can give us. Tobo, tell Adivao to give us the answer. Now she's talking now.
If she would like to volunteer, I think, and then after that, Mr. Team Mpela or Team Pela, I get to work in else. I mean,
Oh,
Mpela.
at the while talking, I got 2.
Adivao got 2. Okay.
hello.
Mr. Chairperson, yes, we are listening.
Oh,
We are
am I
with you.
chairperson? No, can not I
Yes.
said, I
Yes.
also got 2.
You are currently
times
chairing.
1. Okay.
Yes.
It was 3 times 1 plus 1, which was the square root of 4, which I also got 2. So I believe I am in the same boat as other people.
So are you saying the answer is 2?
Yes.
So you abandoned the American approach this time, eh? We're all in the same boat.
Yeah, no, this time, yeah, we're all riding the same wave at the same point.
All right.
Right.
Members, I agree with you on this answer of 2. That is also what I got. Okay. Choose 3 people to give us an answer to number 11.
I got 0, sir.
You got 0, my sister.
Yes, sir.
Ms. Lentur got 0. Okay, please proceed, Adibao.
How many am I supposed to choose?
3.
3.
And then you will be the last.
Okay, back to problem solver.
Yes, I have the answer now.
Yes. Talk to him,
Yes.
Adibao.
Yes, I got
solver
1.
350.
I got 1. The
Adibao.
answer is 1.
Adibao.
Yes, sir.
I also got.
Yes,
When
the
you
answer is
take this
1.
problem solver got 1. Adibao,
Yes.
Sir.
you are now occupying a powerful seat, so you should be active. Okay.
I got undefined. I don't know if the answer is correct.
You were
Adibao,
supposed to
next
choose
person.
the last person.
Can you hear me?
I can
You were
hear you.
supposed to
Please be
choose
active.
the last person.
Please be active. Next person, please.
So I have a problem with my phone. It's not working well.
Oh, sorry.
But
Let me.
3 people gave their answers. It was Tebogo, it was Adivao, it was problem solver, and Miss Lientour.
Ms. Lentur and problem solver. We are looking for the third person. Who volunteers to be the third person?
I got 1.
I also got 1. Kamogelo
Yeah,
and
I
Lerato got 1.
I also got.
Amorelo and Lerato and
Tebogo.
Tebogo
Hey.
got 1. Now, Ms. Lentur. Ms. Lentur,
Yes, sir.
how are you, my sister?
I'm fine, thank you. And you, sir?
I'm okay. May I humbly request you to share with us step by step how you arrived at 0. Members, please pay attention.
I made a mistake.
Sorry?
I made a mistake. I saw now.
Where?
I took out cos x and then I had cos x times cos x minus 1 in the numerator, and then in the denominator was cos x minus 1. Then I cancel them. And that's after that, that's when I made a mistake.
What was the mistake you made?
I'm trying to follow.
Yeah, it's
Okay.
1.
Okay, Miss Lentur. Miss Lentur. Please, I'm
Yes,
sorry
sir.
to interrupt you. I'm sorry to interrupt you. Please take us through step by step. Then we can be able to see where we can be able to come in or intervene to help you. Okay.
Okay, so
We
after
are here for each other. We don't know these things, but we are learning from each other. Okay. Please don't be afraid.
sir.
Yes, please.
After I canceled cos x minus 1, and then I just got cos x, and then the limit of 1 minus cos x over x is 0, but I thought it was cos x over x. That's why I made a mistake.
Please start from the beginning. I need to identify where you made an error.
Okay, sir. So I took out cos x from the numerator.
Out as a common factor.
Yes, sir.
All right. I agree with that.
And then I got cos x minus 1 in the numerator multiplied by cos x over cos x minus 1. And then I got cos x.
Remember, there's the limit, eh?
Yes, sir.
The limit of cos x as x approaches 0. That is what you had, né?
Yes, sir.
Then from there?
That's where I made a mistake, sir, because then it was just cos x, but then I said 1 over cos x, and then I put it in brackets and I said raised to the power negative 1, because I thought it was 1 over cos x equals to 0 when the limit is approaching 0. But then now I saw the correct one.
Okay, my sister, I agree with you where you took out cos x out as a common factor, okay?
Yes, sir.
In the numerator. So in the next, you took out cos x out as a common factor. Then in the next bracket in the numerator, you had cos x minus 1, close bracket, okay?
Yes, sir.
And in the denominator, you had cos of x minus 1. We agree?
Yes, sir.
Cos x minus 1 and cos x minus 1. Cos x in the numerator, cos x minus 1 and cos x minus 1 in the denominator cancel out, okay?
Yes, sir.
Then you are left with the limit of cos x as x approaches 0, okay?
Yes, sir.
Now, let's talk, my sister. Remember, I requested you to know the the sine curve and the cos curve by heart between 0 and 360. Remember? Long
Yes,
time
sir.
ago. Now, what is cos at 0? Where is the cos? You see, at 0 degrees, where is the graph cutting the y-axis? At 0 degrees, where is the cos curve cutting the y-axis? Ms. Lentur.
Yes, sir.
Can you hear me?
Yes, I can hear you, sir. I can't remember.
Members, please help Ms. Lentur.
1.
Ms. Lentur,
Yes, sir.
did you get that?
Yes, I heard, sir.
What did they say?
1.
At 1. Do you remember? Do you know the cos curve? How it looks like between 0 and 360 degrees?
I think so, sir.
You mustn't think so. My request is that even in your deep sleep, you must know how the cos curve looks like between 0 and 360 degrees, okay?
Yes, sir.
The cos curve as well as the sine curve. That is what I requested you long time ago. That's where the one that we got as an answer is coming from. Is it making sense?
Yes, sir.
Thank you, my sister. Ms. Lendur, now is your turn to take this hot seat. I'm now requesting you to choose 3 people. Call the first person. That first person gives us an answer to number. We were busy with number 11. Now we are going to number 13.
13.
Yes.
Yo,
Ms. Lendur, please be active.
Mr. Tebogo robile.
Okay, sir.
microphone.
Who is Rent Shabangu?
Hi.
Hi.
Let's Shabam is me. So number 13, is it? I think -1. I got -1. I don't know if it's right or yes, but that's what I got.
Thank you,
Okay,
my
thank
brother.
you.
Go to
Thank
the
you.
next one, Ms. Lendur.
Yo. Lirato Makupo.
It's Mokupo.
Ms.
Oh,
Lendur,
sorry,
you must
Mokupo.
not be afraid. Pronounce these people's names and names.
They will come
If
out.
you,
They
if
will
you don't
come out.
pronounce them correctly, then they will help you.
There's don't be scared to mispronounce. It's Lerato Mokupo. And can I also clarify, is it Lientuer?
Yes, it's Lientuer.
Okay, thank you. I also got -1.
Right.
Thank you,
And
Lerato.
then I don't know who's this. I think it's Slami Mandla.
Who? Ms. Lendur?
Yes, Tumani Mandla.
Oh,
Ms.
it's
Lendur, next time
Slumani.
you can use the surname only next time. It's fine. Mandla. I got -1 as well, -1.
Thank you, Mr. Mandla. Now, Chairperson, is your turn. What did you get?
So I didn't do that yet. I wasn't here for the classroom 7 yesterday because I had another class.
Oh, I remember. Okay. Now, please, Ms. Lendur, please,
Yes, sir.
Mr. Shabangu, Lerato, and Mr. Mandla, please choose anyone to explain to us how they arrived at -1.
But must I choose, sir?
Yes, please.
Mandla.
All right.
Miss
Yeah.
Lendur. Okay, hang on, Mr. Mandla. Miss Lendur,
Yes, sir.
please get a cup of coffee, a cup of tea, and you can even pour 12 spoons of sugar so that you can have energy to talk.
Diabetes.
I don't know. Miss Lendur seems to be lacking energy, or am I the only one who's feeling that? Miss Lendur, what's wrong?
We are together. Sir.
Nothing, sir.
Please be active, be active. Okay.
Yes, sir.
Thank you, my sister. Yes, Mr. Mandla, please proceed.
All right. Thank you very much, sir. So the question says the limit of x as x approaches pi/2, right? And then f of x is cos squared x sine squared x -1. So first with the denominator, I use the identity sine squared plus cos squared equals to 1. And then I got negative cos squared of x. And then from there, I substituted pi/2 for the x. And then we know that pi over 2 is 90 degrees. At 90 degrees, sorry. Yeah. At 90 degrees, cos x passes passes the y-axis at 1, right? So something like that, but it's 1 over 1 because it would be 1 times 1 in any event, so it's 1 on both sides. And then that's how I got -1. But for a better explanation, I defer to Tebo.
I just heard my name. Sorry?
Yeah, no, I defer
They
to
say
you
you
for a
should give
better
us a
explanation.
proper. They say you should. Yeah.
Give proper explanation, Demo. Please
Oh,
proceed.
no.
Progress.
The cos
Now-
is the cos squared x cancelled out. Sorry,
number
guys.
two.
Yeah, cos squared x cancelled out. But yeah, Teboho, you can go ahead. Cos squared x cancel out, which is 1 divided by -1, which made -1. Sorry. Yeah, it's been a long day.
Hey,
Teboho, you can go ahead.
Oh, okay.
my brother, yesterday,
Yes.
man, I don't know if I can talk yet. May I?
Yeah, you can go
Okay.
ahead.
I had the same situation yesterday, that you're having, but then I'm stuck with that limit as x approaches pi over 2 and nothing to substitute it into because now everything has cancelled out. But after I reassessed it, I found that I can have the difference of 2 squares, so it will be sine x plus 1 times sine x minus 1, and then I changed the numerator to that as well, and then the sine x minus 1's cancelled out, and then I had 2 over 2, and then I had a positive 1, and everybody else has had a negative 1, so, and that's what I had yesterday. So I am in actual fact not 100% confident myself about where I'm standing, but I would suggest anybody who is confident and understands this, may you please help us.
So I
No,
have a
I used a different approach. I used something different, but
Okay,
it's
come on.
also an
What did you
identity
use?
though. I said I changed the the denominator.
Mm-hmm.
I factored out negative. So it
Okay.
was negative bracket negative sine squared x plus 1, and also the same as negative bracket 1 minus sine squared x, which is also cos squared x. Then the cos cancel out, then it's 1. Negative times 1 is -1.
Mm-hmm. That's
Yeah,
what I
isn't
did.
that the same as, it's more or less the same as what I did, right? Because it all
Mm.
ends up in
It is
1
the
over
same.
-1.
Yeah.
Oh, okay.
I think, sir, correct me if I'm wrong. A while ago, when we were doing the first introductions to limits and rules for them, isn't it for if this constant, right, was a function? Because at the last step before we get our final answer, we have the limit of -1 as x tends towards pi over 2. If we took that as a function that's -1, so y is equal to -1, the limit for a function that's a constant is just the value of the function, right?
Oh, yeah.
That's
okay.
when you were saying you were confused, Tebogo, about like, but now there's no way to substitute it in.
Okay.
Lerato, I hear what you are saying, and then if I were to be sent to jail, then you would be at the front to go to jail. Okay? Then I'll be following you because ideally I would be the person who actually misled you. So then I would be behind those that I misled. So I'll be leading them to that jail cell. Okay.
Okay, sir.
Now, in this case, I fully agree with what you just said. Because the way I approached it, I realized that, okay, sine squared x minus 1. In the numerator, we have got cos squared x. No problem. But in the denominator, we have got sine squared of x minus 1, which is equals to negative cos squared of x. Do we agree?
Yes, sir.
Therefore, cos squared of x over negative cos squared of x. I ended up having the limit of negative 1 as x approaches pi over 2. This is the limit of a constant. So just equals to the constant, which is negative 1.
Okay, sir. Sir, you made it seem like it was a bad thing because now we're going to jail. Could you not have picked a happier comparison, sir?
I did. What did I do, Leonardo?
So you said if you misled me into thinking what I thought, then we'd both be going to jail because you're the one who misled me. But sir, in this case, we are together in our understanding and approach to the question. So all I'm saying is, saying that we're going to jail, why aren't we going to a party or to a celebration if we're in agreement, sir? Because it's not that you misled me, because we're both understanding and our answers are correct, no?
Yes. No, what I was just trying to say, I was just emphasizing the fact that I agree with what you said, because that is what I said earlier in the beginning. Because what actually made me happy was the fact that you remembered back when I said that. And now it came into play here.
Yes, sir.
Yes.
I suppose you saying we're going to jail did have a bigger impact. So it's fine. It's
All right. Thanks. Members, is it clear how we arrived at negative 1 to everybody? Including Miss Lendur.
Yes, sir, it is.
Miss Lendur,
Yes, sir.
ma'am, I'm very much worried about you. Do you know that?
Yes, sir.
Do you understand? Miss Lendur, my sister.
It's so sorry I have to go out fast.
Miss Lendur,
Yes, sir.
are you okay, my sister?
Yes, I just had to go out quickly. Sorry.
Please talk to us where you don't understand. We'll help you. We are here for each other, okay?
Yeah, so I just did the same thing that the first person did, which was use the identity sign squared x plus cos squared x is equal to 1. But I didn't use the other methods that they used.
Okay. What did you say? I need to follow.
I also use the identity so that 1 is sine squared x plus cos squared x is equal to 1. And then I got negative 1.
How did you arrive at that negative 1, if I may ask?
So when you substitute sine squared x plus cos squared x into the numerator, then multiply the negative by it, then it's going to be minus sine squared x minus cos squared x. So in the numerator, it's going to be sine squared x minus sine squared x minus cos squared x. I mean cos x squared, sorry. And then you're going to get negative cos x squared.
Ms. Lendur, please start from the beginning. I need to be convinced. I'm requesting you to convince me.
So, sir, I substituted sine squared x plus cos squared x into the denominator is 1
In the
because
denom-
1,
Okay, in the denominator, what did you do, my sister?
since 1 is equal to sine squared x plus cos squared x, I substituted it into the denominator in the place of 1.
In the place of 1, you substituted cos squared x plus sine squared x.
Yes, sir.
Okay. Then from there,
And then I got it. Then I multiplied the negative by it, then it was sine squared x minus cos squared x. Negative sine squared x minus cos squared x.
hang on. Please. No shortcuts. Miss Lentur,
Yes,
you said
sir.
we have got a negative, and then you said in the place of 1, you put sine squared x plus cos squared x. Okay?
Yes, sir.
Please take it from there.
Yes, sir. And then since
I agree with what you said. Then please proceed from there.
yes, sir. And then since it's minus sine minus 1, I multiply the minus by sine squared x and cos squared x. So then it became the denominator became sine squared x minus sine squared x minus cos squared x. Then sine squared x cancelled because it's sine squared x minus sine squared x. Then I got cos squared x over negative cos squared x.
Yes, I agree.
Yes, sir. And then those two cancelled, and then I got negative 1.
Ms. Lentur,
Yes, sir.
okay. Please let me share this little piece of advice with you. You know, in this world,
Yes, sir.
this world in which we are living in, when you talk to people, you need to talk, or you need to speak with confidence. Okay.
Yes, sir.
Otherwise, people won't have faith in you. Let me give you a typical example. Who can I? Okay. Do you know Barack Obama?
Yes, sir.
Have you seen that man talking?
Yes, sir.
That man speaks with confidence. Is he not?
Yes, sir.
Who else? Let me look for another person. I'll look for another person.
Skaya go le Trump o bolela ka confidence menya.
That one. I don't know how that one thinks. That man. I really don't understand how he thinks, that one. I'm looking for another one. Let's look another person who speaks with confidence.
How
Except
about
except Trump.
Chabombek.
let's try Glenn Madiba. How's Glenn
Okay. Thabo Mbeki, one of those people. You see, with the former president, Thabo Mbeki, he speaks with confidence, but most of the time with a low tone. Have you noticed that?
Yes.
With confidence, but with a low tone. Who else? Looking for another one. Looking for another one. Who comes to your mind, people?
Glenn Madiba. I think she just like here.
Really? Am I speaking with confidence?
That's a good one. That's a good one.
Am I speaking with confidence?
Yes.
Let her be the Let her answer that question.
Okay.
What does
Thank
she?
you. Sorry?
What does she think on that? What does she think? Does she think you'd speak with confidence or what? Let her answer that.
Miss Lenture, what are you saying?
Yes, so you do speak with confidence.
See, she gets the idea.
Thank you. I mean, people, we are not in a different world from where we are. I mean, we are not isolated from these other people that we are living with. We are living with them. Remember, Miss Lenture, tomorrow you might be one of these powerful people in this world. And I will be very happy to say, I know Miss Lenture. Miss Lenture.
Yes, sir, I hear you, sir.
I'll be proud. I'll be happy to say, hey, I know that one. But now, if you speak like, hey, you are very, very sick, I'll say, no, I don't know that one. You get me?
Yes, sir.
Yes, please, put energy, man. Put energy. Energy. I'm looking for the last person now. All of us, please, let's think of one more person. One last person.
I keep on seeing Glenn Madiba in my brain. Let's just write it boldly. So it's Glenn Madiba. Sorry.
Okay, including myself in there, but now let's look for another last person.
I think Lerato. Is it Lerato here? Is it Lerato?
Lerato.
Yeah,
yes.
She did well.
Yes. Lerato.
Yes, sir. Thank you, family members.
My sister, you will go places. You will go places. I have faith in you. And then you know what? The reason I'm saying this, it doesn't mean that being at the forefront, you know everything, okay? It doesn't mean
Yes,
that.
definitely, sir.
It doesn't mean that being at the forefront, one knows everything. So being at the forefront or being a leader, then you take this responsibility for leading these people to say, okay, this is what I'm confident with. But with this, I'll need your support. Okay. Then the people will support you. Then you will lead them.
Everybody's good at different things. So if someone is better in another thing, it doesn't make any sense to as someone who's less experienced or less knowledgeable to try and say, nah, but let me talk on this topic. If I don't know, I must be confident in saying I don't know.
Yes. Yes. Then those who are confident then will be able to come in. Then from there, with that confidence, then you'll be able to lead. That's why I'm saying, as a leader, you need to be able to say, people, I know I'm a leader. Boldly so to say, I'm a leader. Based on the fact that you might have been chosen to lead the people at that point in time, then you'll request them to say, okay, please, this is what I think is the direction to take at this point in time. Please, let's follow this direction. Along the way, when you notice that you took the direction that you were not supposed to take, you need to stand again boldly and say, we need to change direction now. The direction that we are taking is not taking us where we are intending to go. Then the people will follow you. Unlike just saying, we just go there. We just go there. Even if you are misleading people. It doesn't work like that. It doesn't. People, some of you are already in those positions now where you are leading other people. Please lead them with courage, knowing where you are taking them. Those who are not in those positions, the day that you will be in those positions, please lead with courage and with the wisdom that you would have requested from God. Then, in that way, you'll take the people where you should actually take them. And then, please, be ready or be prepared to take advices from the other people. In that case, then you will go places. Ms. Lendur, you make me talk too much now. Okay.
So, Minir,
Yes.
so yesterday we did a squeeze theorem, right?
Yes.
And Mr. Mukone came with 2 questions, but today he's not here. I don't know if we should do them or...
I didn't forget about that. What I'm going to do, as I said, I'm going to sit down, okay, and prepare a list of questions based on the squeeze theorem, so that all of you can be able to comfortably be able to handle all questions related to the squeeze theorem.
All right.
But then, having noticed that we had already started with these questions, then I just said to myself, no problem, let's finish with this. Then at the end, then we'll go back and specifically focus on what I promised. Unlike jumping from here to there, jumping from here to there, I don't want to confuse you. I didn't forget. That is what I'm going to do. Okay. Thank you. Yes. Where were we? Ms. Lendur?
Yes, sir.
Where were we?
You were asking everyone for their answers, I think.
Answers for what now?
No, you were asking me for my answers, sir, last. On 13.
On 13.
And then I gave the answer.
To be what?
To be -1.
-1. Yes.
Yes, sir.
I agree with the -1. But the problem that I have with you, did you get the problem that I have with you?
Yes, sir.
What is it?
I don't speak with confidence.
Please speak with confidence, my sister. Okay?
Yes, sir.
Thank you.
Okay.
I agree. Answer to number 13 is, in fact, -1. Is there anyone who has got a different answer from -1? No one. Okay. The answer should be negative. There is this person. Deborah. Deborah.
I am here. Sorry.
Hey, what did you get, my brother, as an answer to number 13?
Okay. Let me be honest.
I'm worried about you and Miss Lendur in this workshop.
Yes, sir.
If you two, and then, okay, let's say from now on, you two, you are going to alternate by being the chairpersons for today. You two. Okay?
Today.
For today's workshop. If it is not you, it's Miss Lendur. All right.
Okay.
What did you get as an answer for number 13, Deborah?
Initially, I got +1, and then I realized my mistake, and then I realized it's actually -1.
Yeah. Okay.
So,
now, okay. Deborah and Miss Lendur, can
yes.
the three of us have our chat here? Deborah, you will lead. Miss Lendur, you will lead. And then, in the process of leading, you will be the first person to give us an answer. The people that you will call out their names will follow. Okay?
Okay. Just okay.
Can we agree on that one?
Sir, can I just ask what questions did you give yesterday?
It was 5, 7, 9, 11, and 13. Okay.
Okay, sir.
Now, okay, you two choose. Who takes the hot seat now? You two. You talk between yourselves, and then you tell me. If you fight, I'm not part of that fight. But you two choose, and then you tell me.
Are you confident going first, or should I volunteer to go first? Should I be the one to go first?
I'll go first, if it's okay.
No, I'm good. I just okay, yeah, I'm all right. So yeah, so sir, then I'll be on the hot seat. I'll just be making sure the fire is hot when she comes.
Okay, who am I talking to now?
Get
Who am I
that
talking to now?
sir.
Oh, Miss Lentur. Oh, to Tebo.
Sir,
between
I switch off my video so that I can hear, because my reception is very poor. But I don't know if
I'm saying, my question is, between the two of you, who is taking the hot seat now? We need to proceed.
okay. I'm the hot seat. I'm the one that's going to go first, and then thereafter
Okay.
she'll come
right.
yeah.
Thank you, my brother. Our next exercise is number 15. Number 15, Deborah, since you are now at the center stage, how many minutes are you giving us to work it out?
I believe our benchmark is 3 minutes or 2 minutes? I can't remember. Sorry, if somebody can just remind us how many minutes we have prescribed.
You make a decision.
I think like 2 minutes.
You yourself.
Yes, 2 minutes. 2 minutes.
Which one are we
2
doing?
minutes. And then
Number 15.
15. Okay.
Yes. And then Deborah will lead us in sharing his answer with us before he calls other family members. Deborah, are you comfortable with that 2 minutes?
Yes,
You
I
yourself.
am ready. And I'm yes.
Okay.
Sorry, sir,
Okay.
I had to go out. Which one are we doing?
We are now working out number 15. And Deborah has given us 2 minutes.
15 or 16?
15.
Okay.
So are there other ones that we have to do after this?
Yes. You see, we've got a
Which-
long list here. Remember
Which ones are
what
we
I
going to
said
be?
yesterday?
It's 15, and then which one are the other ones? Or are we going one by one?
It will be 15. The next one will be 17. After 15, we'll go to 17.
Thank you, sir.
Okay. All right. Then, if you are done, please share your answer with us and then get 3 people from the family members to see what they got as an answer. You yourself, what did you get?
I myself, I got 1 as an answer.
You got 1. Thank you.
Yeah, no, on this one I'll speak like Leseche Kganyago, no confidence, but yeah, we did number 15, right? I
Yes.
got pi over 2.
Pi over 2.
Yes.
Okay. Thank you. Please proceed, Deborah.
Okay. Am I allowed to ask the person I'm sharing the hot seat with, maybe, or if that person is comfortable sharing their answer?
Yes.
Okay, Miss Liantuar. Maybe are you comfortable sharing?
Miss Lentour. Miss Lentour. My sister.
But I still can't get it.
I saw.
Yes.
I got for number 15. I got pi over 2.
What did you get?
Pi over 2.
Pi over 2. Okay.
Yes.
Thank
Sir.
you. The last person, Debo.
A problem solver. My brother. Evening. May you please share your answer with us? Are you? Yeah.
Hello. Yes. In number 15, I have 15 over 2. Actually, sorry. That is pi over 2. Yes, it's pi over 2.
Pi over 2.
I'm the only person who got one.
Debo.
Yes.
Oh, thank you, my brother.
Yes, sir.
Thank you, problem solver. Debo,
Yes, sir.
please share with us how you arrived at 1.
Okay. Where? 15. Okay, I have pi sine h. The limit of pi sine h over 2h as h approaches 0.
Is equals to?
I then. Oh wait, how did I get 1?
That is the question that you should answer.
Oh. Wait, wait, because I have here. I've written pi 2 times 1, and then oh my goodness, because I said sine h over h is 1, and then I had pi 2, so I separated them. I see I'd made a mistake, and then I believed it was as h approaches pi over 2, and then so my apologies, family members. It is pi. I also got pi over 2. I accidentally substituted pi over as h approaches pi over 2 in my and then it became 1. But here sine h over h is 1, which was h over 2 times sine h. I mean pi over 2 times sine h over h, which gives pi over 2 times 1, which gives pi over 2. So I believe I am in the same boat as everybody.
Debo,
Sir.
you see why am I worried about you?
Yes, sir. Yes, sir. I'm there as well.
Okay. Pi over 2. This is the limit of this is the limit of pi sine h over 2h. This is equals to pi over 2 times the limit of sine h over h as h approaches 0. Then we know that the limit of sine h over h as h tends to 0 is 1. Then 1 times pi over 2 is pi over 2 double. Confident.
Yes, sir.
This is what I expected from you, to explain this, the way I just explained to you with confidence. But then
Yes,
I
sir.
got lost. You see, in the process, I got lost. Do you get me?
No, I understand. The angle said and we buckle under the pressure and we'll make silly mistakes, you see. So I do believe I am somewhat close to being on the right track.
What you are, my brother. You are with me. I'm with you.
Yes.
Please hold my hand. Hold my
Yes,
hand.
sir.
I want to walk
Yes,
side
sir.
by side with you.
Yes, sir.
I don't want to leave you behind. Don't be afraid of anything. Okay. Thank you, my brother. Okay. Is there anyone who disagrees that the answer to number 15 should be pi over 2? Okay. We seem to agree. The answer to number 15 should be pi over 2. Miss Lendur, number 17, please take the hot seat. Miss Lendur?
Yes, sir.
Yes. How many minutes are you giving us to work out number 17?
Maybe 5 minutes, sir.
I
1 minute, 1 minute. Yeah, that one deserves 1 minute.
Yeah.
Miss Lendur, I
Judicial.
disagree with I disagree with 5 minutes, Miss Lendur. Miss Lendur, please, let's talk. Lead, my sister, please lead with confidence. How?
3 minutes in, sir.
Sorry?
3 minutes.
What?
3 minutes.
3 minutes. And then you are going to be the first one to give us the answer, okay?
Okay, sir.
Thank you, my sister. We'll accept that 3 minutes, even though this can be done in less than 3 minutes. Okay, we'll go with the 3 minutes that time.
So I'm stuck on number 17.
You are stuck.
Yes, sir.
Okay. Now, please take us through slowly, step by step, how you started, and then where you stuck, so that we can be able to help. Please, Ms. Lendur, please call all the family members to wake up and listen to you, so that they can be able to help.
Guys, everybody else done?
Yes.
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 Yes, Lentura.
Okay, so I multiplied by the conjugate of the denominator, which is 5x plus 10. I multiplied the numerator and the denominator by 5x plus 10.
Mm-hmm.
And then in the numerator, it was 5x plus 10 times sine 2x minus 4. And in the denominator, it was 25x squared minus 100. But then if I substitute 2, then I get 0 in the denominator, which is undefined.
Ms. Lendur?
Yes, sir.
Yes, number 17. You say you multiplied by
5x plus 10 in the numerator and the denominator.
why, my sister?
Because if I directly substitute in 2, then I'm going to get 0 in the denominator, which is going to be undefined.
Okay, you multiplied both numerator and denominator by 5x plus 10. Then from there?
And then in the numerator, I got 5x plus 10 times sine 2x minus 4. And in the denominator, it was 25x squared minus 100.
Then from there?
Then I tried to substitute 2 in, and then I saw when you substitute into the denominator will be 0, which will still be undefined.
Okay. So are you getting an undefined answer?
Yes, sir.
Okay. What is your view? Do you think that by so doing, you are getting us out of Egypt to Canaan, or are you retaining us in Egypt?
What do you mean, sir?
Not
No,
the
no,
Bible
no.
references.
Yes, that is the Bible reference. Yes.
The second you said Egypt, I was like, no way.
I mean, what you did, are you leading us to Canaan or are you retaining us in Egypt?
I think I'm retaining y'all in Egypt, sir.
Sure. Is that where you would like us to remain?
No, sir.
Members. Okay, thank you, Ms. Lentur. Please ask 3 people, Ms. Lentur, what they got as an answer. So from your side, I'm noting here, Ms. Lentur is undefined. Yes. Now is your turn to choose 3 people and ask them for their answers.
Okay, so Kamugelo
Yes.
and
One
Tebogo.
is a time. We need an answer.
Oh, okay, sorry.
First. Yes.
Oh, I got 2/5.
2/5. Ms. Lentur, please proceed.
Okay, and then next is Tebogo.
I also got 2/5.
2/5. Please proceed, Ms. Lentur.
And last is Adivao.
2/5.
Adivao, 2/5.
2/5.
Thank you, my sister. Ms. Lentur,
Yes, sir.
amongst Kamogelo, Tebogo, and Adivao, please choose anyone to explain to us how they arrived at 2/5, which I'm in agreement with.
Okay, I'm gonna ask Kamugelo, sir.
Okay.
Can you please explain?
All right. So number 17 says find the limit of sine of 2x minus 4/5x minus 10 as x approaches 2. So what I did first is factor out common factors from both binomials, which is going to be sine of 2 bracket.
Okay. Who can help?
Can I try?
Hey, your name, ma'am?
Adivao.
Yes, my sister. Yes, Adivao.
Okay. First thing that I did, I took out the common factor from the denominator, which is 5. Then I got sine 2x minus 4/5 into x minus 2. Then from the numerator, I took out the common factor of 2. So I'll have sine 2 into x minus 2 over 5 into x minus 2. Then I said sine 2 into x minus 2 over x minus 2 multiplied by 1/5. After that, I multiplied the denominator and the numerator of sine 2x minus 2 into x minus 2 over x minus 2 by 2/2. Then I'll have 2 sine into 2 into x minus 2 over 2 into x minus 2 multiplied by 1/5. Then I'll
Can
have
you just repeat that step again? Sorry. That's where I'm getting lost.
which one?
That step that you just did now.
For multiplying by 2.
Yeah, so what did you multiply by 2?
Sine into 2. I don't know what it's called. I
please
forgot
request
what
in
it's
this way?
called.
Please start from the beginning, my sister, slowly, so
But
that
I'm
people
fine
can...
with the beginning. It's just that
Oh,
part I'm confused
oh.
about.
Okay, let me keep quiet.
Because
Please
you
talk to
said
each other.
before that it was 1/5, right? Sine
Okay.
2 into x minus 2 over x minus
X
2.
minus. Yes.
So
Then
then in the next step, what did you do?
I multiplied sine 2 into 2 minus 2 over x minus 2 with 2 over 2.
Okay.
Then I have 2 sine into 2 into x minus 2 over 2 into x minus 2 multiplied by 1/5. Then after I'll have 2 into 1 multiplied by 1/5, which is 2/5.
And you do that because you can 2 over 2 is the same as multiplying by 1, and multiplying any number by 1 has it remain the same, right?
Yes.
So that's why you did the 2 over 2.
Yes.
Because I was confused. I didn't know now how to, because I could see that the sine 2 into x minus 2 and then over x minus 2 was almost looking like something we know we can get the value for. But then I forgot that we could multiply by 2 over 2, which is basically 1, and leaves the expression the same.
The thing that is called, I forgot what it's called, but it's called something where we multiply by 2 over 2. Zed, do you know what it's called? I forgot.
Adibabo,
Yes, sir.
what you are talking about is similar. Were you here yesterday?
I had an issue with network.
Okay. Who are you talking to, Adibabo? Is it
Lerato.
Lerato?
Yes.
Lerato?
Yes, sir.
Remember yesterday there was another exercise that I displayed and paused for a while. And then I requested all of you to make sense out of it. Yesterday, remember? You forgot.
I'm trying to remember, sir, which question it was. Is it the one that was like yours, so we were still chewing even after we were done with the question?
Is there one we
It
were
was so
what?
much to digest, sir.
I think is the one. And then I think
Where we were
you,
explaining between the steps. And we were
I think
looking
is,
at it and we were like, how did they get from this step to the next step? And then at one point you said, just look at it as if it was the first part and then the last part.
yes,
Yes, sir.
yes. And I remember you saying you said you took a what?
A
Picture.
screenshot, sir.
A
Yes, sir.
screenshot. Yes, that's the way. You said you took a screenshot.
Yes, sir.
Remember that exercise? That is its application here.
Oh. Okay, sir. I see it now.
Is the bell ringing?
Because that one we had to manipulate it as well by timesing by a fraction. That was the same at the top as it was at the bottom.
Yep.
Okay.
Is a bell ringing?
Okay,
thank you. I like
it's
that bell to keep on ringing. Sorry?
It's deafening.
Okay, I'm happy there. Adiba,
Yes, sir.
hey, where were you? I think in your explanation, where were you?
I was done.
Oh, where were you done?
Yes, she was.
Oh, okay. Then, Chairperson.
Sir, yes, I still don't understand. Sir, I got lost. After she took out the common factor from the angle and from the denominator, I got lost.
Chairperson,
Yes, sir.
Miss Lendur,
Yes, sir.
I've given you this position. All the powers. You have got all the powers. You can ask different people to who said? Deborah said 2/5. Camarelo said it's 2/5. Adiva said it's 2/5. I also got 2/5. Now you have got these people. If the other one, if you didn't get it clear from the previous person, you can go back to another one and ask that person to explain it until it makes sense to you.
Okay, sir. Then
That is
can
the
I ask?
position that goes with the power of that seat that you are currently occupying.
Yes, sir.
I'm keeping quiet. I'm now sitting at the back seat. Please go ahead until you yourself understand. Remember, you too, I told you that I've got a problem. No, I'm not having a problem. I'm concerned with you and Deborah. That's why you two are alternating this process of chairing.
Okay, then since Lerato understood what she said, can you please explain, Lerato, how you got the answer?
Okay, I'm currently in the process of looking for the screenshot I took yesterday because I feel like if I look at it again, it will also just make it that much more solid in my memory and my understanding. So basically, yesterday's problem was remember yesterday sir showed us that what was it? Is it a theorem? Is it a rule? But it was the limit of sine x over x as x tends towards 0 is equal to 1. That was a
Yes,
theorem that sir gave us yesterday, right? And the
yes,
condition for this is that its sine trig function in the numerator and that angle for that trig ratio is the same angle or the same value that's in the denominator. So in this case, in the form sir gave us, it's x and x, right? So for this question, we have sine or the limit as sine 2x minus 4 over 5x minus 10 as x tends towards 2. We're going to need to have to get it in that same format where it's the ratio's angle over its angle. Does that make sense?
yes,
Okay, so we start by factorizing the denominator and the angle in the trig ratio. So in the numerator, we take out, no, wait. So I must try and explain it the way that the question did it yesterday. Okay. So, but yes, technically we would still need to factorize. So let's factorize the denominator. We take out a 5, okay? And then we have 5 bracket x minus 2 in the denominator, right?
yes,
So if we write up as a next step from the first step, we'll have the limit of sine 2x minus 4 over 5x minus 2 as x tends towards 2. Then we move that 1 over 5 out of the fraction. So then we'll have 1 over 5 times sine 2x minus 4 over x minus 2. Okay. Then we see that it doesn't look the way we need it to look, right? Right now we have in the trig ratio 2x minus 4 and in the denominator x minus 2, but we need them to look the same, right? So that's where we times everything by 2 over 2, which is the same as timesing it by 1. So if we times that by 2 over 2, we end up having the limit of 1 over 5 times 2 times 2 over 2, or yeah, let me just say it like this, and then we'll simplify it in the next step. So we had the limit of 1 over 5 times 2 over 2 times sine 2x minus 4 over x minus 2, right? Then to get it to look the way we need it to, so that we can simplify that expression to 1, we'll say the limit of 1 over 5 or 2 over 5, right? So we took the top half of the 2 and we put it with the 1 over 5, and then times sine 2x minus 4 over 2x minus 2. Sorry, wait, sine 2x over 4 over 2 times x minus 2, timesing by 2 over 5. Does that make sense?
Yes.
Okay.
Can I?
Yes.
Sorry, I get that, but because I also did it. But now that doesn't that only apply if x approaches 0, but here x approaches 2 and not 0.
Yes, that's what my question was as well. That's why I was looking for the photo I took yesterday. Because yesterday I wanted to know if that was also the case. Yeah, okay. So for yesterday's one, the limit was as h tended towards 3, which isn't 0 like the original, like basically the general theorem that Sir gave us. So Sir, or Flumile, or sorry, Flumani,
Yeah, no,
Mandla.
let's stick to Mandla, guys. Yeah, let's stick to Mandla. It's
Sorry.
fine. Can I ask then, Braglen, since it says that our x approaches 2, right? Can we not assign an arbitrary term, say beta, and then we say beta is equal to x minus 2, and then for beta approaches 0, we say that the 2x minus 4 on top will be 2 multiplied by beta, and the one underneath will be 5 multiplied by beta, and then we take it from there. I'm not sure if I'm confusing everyone even further.
Yeah. Are you saying we replace the 2 with a beta?
Yeah,
like,
we replace the x approaches 2 with beta equals to x minus 2. And then we have another expression where we're saying we're looking at the limit of beta approaching 0. And then so the top will be sine beta, sine 2 beta, because it's x minus 2 multiplied by 2, which is 2x minus 4. And then the one underneath is x minus 10. And then you take, x minus 2. If you take out the 5, you leave x minus, I don't know if you guys are understanding me, but it will be 2 beta on the denominator.
But Sir, that what Manja just said is making me wonder, for questions where we apply that theorem that you showed us, we've never had an instance where we actually had to substitute in that value. So does the value not matter what it tends towards then?
Okay. Thank you for, yeah.
There's lots of questions.
No, don't worry. Miss Lendur.
Yes, sir.
You must wake up, wake up, wake up, wake up, wake up, wake up, please. Miss Lendur.
Yes,
are
sir.
we safe in your hands?
Kind of, sir. I still don't understand why it's the same.
No. Beside you not understanding, because that is what we need to clear. Everybody has to understand how we arrived at 2 over 5. But my question is, are you yourself? I'm not referring to the question. You yourself, are you okay? Beside not understanding how to get to the answer.
Yes,
Have you been following this explanation from different people? Probably you are confused, but that confusion mustn't actually make you drown in this pool. Okay.
Yes, sir.
If you're unable, my boss usually says, clear skies don't make what?
Good pilot.
Good pilots. Yes.
Oh, damn.
In this confusion, you somehow have to find your way out. Okay. That is what I mean. You have to say, okay, yes. Hey, Ms. Lendur, you need to be in a situation where you will be able to analyze. You need to analyze, be analytic, to say, okay, I'm confused by that. So and so said this. That is what is confusing me. So and so said this, and I'm getting confused by A or X or Z in there. In there, I'm confused by 10. Do you get me?
Yes, sir.
So that when the third person comes in, then you can be able to make a comparison or an analysis of where this 10 is coming from compared to these two people who have already confused you, so that you can be able to find your way out. That is what I mean. Okay. Now, Ms. Lentur,
Yes, sir.
let me come in now. I'm in your capable hands. Okay. Please, lead me. Here we are having the sign of open bracket 2x minus 4. We have got the limit of sine of 2x minus 4 all over 5x minus 10. As x approaches what, Ms. Lentur?
2.
X approaches 2. The next thing that I will do, that I did, I said this is equals to the limit of sine of open bracket 2x minus 4. Okay?
Yes, sir.
In the denominator, I had 5 open bracket x minus 2 as x approaches 2. Okay? Are you with me?
Yes, I'm following, sir.
Then the next thing I said, this is equals to the limit of 2 times sine of open bracket 2x minus 4 close bracket. Are you with me?
Yes, sir.
All over 2 times 5 open bracket x minus 2. Still with me?
Wait, okay, sir, can I just ask, did you multiply now the numerator and the denominator by 2?
Yes.
Okay.
Still with me?
Yes, sir.
Next step. This is equals to, because we know that 2 and 2 is just 1. Okay?
Yes, sir.
So now this is the same as equals to 2 over 5 times the limit of sine of 2x minus 4 all over 2x minus 4 as x approaches 2.
Yes, sir.
Sine of 2x minus 4 over 2x minus 4. That's 1. Do we agree?
But Glenn, is it still 1 if it's approaching 2, the x? Doesn't the x have to approach 0?
Doesn't x? Yes.
Yes, sir.
Yeah,
Zero.
so that's why I was explaining it the way I put in the messages, because I understood it. We have to make something that approaches 0.
In this case, remember, in this case, we have to deal with the angle. We need to make the sign, the angle of this sign to be similar to that one in the denominator. As in this case, x is tending to 2.
So, from the previous, from what you showed us originally, which is that
Yes.
the limit of sine over x as x tends towards 0 equals 1. That 0 that the value that x is tending towards can vary, right?
Yes.
Okay, that was our question because we thought it only was applicable for sine and its angle, whatever the angle is. We understood the angle could change, but we didn't know that the value that x tended towards could change, and then that meant that it would still stand.
It
So
still stands.
if we can rewrite then that theorem that we were given, is it safe to say that it can then be written as the limit of sine of x over x as x tends towards a is equal to 1? Because then we know it's variable.
Yes.
Okay, sir.
Hmm.
Thank you, sir.
Thank you. You're welcome. Miss Lendur,
Yes, sir.
did you hear me?
Yes, I heard you, sir.
Did you understand?
Yes, I understand now,
Should I
sir.
repeat what I said?
No, but I just want to confirm, sir,
Yes.
because before you explained, I thought maybe the reason why you said it's equal to 1 is because 2 is a multiple of 4. So if we equate 2x minus 4, then x will equal to 2. And then similarly, when you say sine x over x, since the x is not equated to anything, and x is approaching 0, that's why it's equal to 1. I don't know, I think I understand it better now, sir, than what I was assuming.
Okay. Here is my request to you, Ms. Lendur. Please repeat what was confusing you and explain to us. Please explain to us what is it that was confusing you, and then explain. What should I say? Okay, please explain to us what is it that was confusing you and what is no longer confusing you now. That is what I need to say.
First, I thought you had to substitute 2 into the equation. That's why I thought it was undefined. And then when everyone was like, they got 1, when they isolated it and they got 1, I thought that the reason why we got 1 for sine 2x minus 4 over 2x minus 4 was because 2 is a multiple of 4. Or because if you equate 2x minus 4 equals to 0, you get x is equal to 2. That's what I thought just after everyone explained how they got to the answer. But now that you explained it, sir, I understand now.
Are you sure?
Yes, sir.
Thank you. Please, do you understand, Ms. Lendur?
Yes, sir. So, sir, can I ask, so this will apply to any number? I think
Yes.
Lirato or someone said, so it's x, as x approaches 8. Whenever we see trigonometry, what's the name? Sine x and cos x or so. And
I
we
think
can,
this one's only for sine x.
does it only apply to sine x?
Yes, as far as my understanding goes.
Mm.
But the the number that x tends towards can be any number.
Yes.
It's variable.
Hmm.
So you can replace the 0 in the way you wrote down the theorem with like beta or alpha or something. So you know it's also variable.
Yep.
So this applies to 1 minus cos x over x as well.
1
This applies
minus
to what?
1 minus cos x over x as well, because the limit of that is 0.
that are you talking about the other theorem that
Yes,
we were?
the other theorem.
No, that one's a different one. I don't know if we can also say if that one's variable, because that one we used conjugates to solve. Or its application was with conjugates.
So what is the is it only
I see where Miss Lendur is looking at. Miss Lendur, you are looking at number 29, eh?
no? So I'm looking at my book of the theorems now. Now I'm trying to find out, does this apply to all of the theorems?
So
Please.
remember the theorem you showed us yesterday. The
Yes.
limit of cos x minus 1 over x as x tends towards 0 is equal to 0.
Yep.
I think she's
So
inquiring about that one.
So if x approaches another number with that theorem as well, will it still equal to 0 also?
Yes.
And with tan x over x as well also, sir?
Sorry?
With tan x over x as well?
For tan.
Yeah, tan x over x is equal to 1.
Miss Lendur,
Yes, sir.
here I will not be your roommate in prison. On that one, you are alone. I can be your roommate in prison in this when you apply this. Okay? And then this is what Lerado asked to say. In this case, x was not approaching 0, but x was approaching 2. Is this still holding? Yes. Because remember, in this exercise that we were battling with, the challenge was to make this angle to be similar to this. All right.
Yes, sir.
Are you with me? Then
Yes, sir.
with this one, yes, in a small prison, I can go with you. This one, in a small prison or medium prison or even maximum prison, for both of them, I'm prepared to go with you. But if you are using something that is not related to this, sorry, I'll ask them to arrest you alone. Ms. Lendur, are you with me?
Yes, sir. Yes, sir. I'm with you, sir.
So, with the application of this, no problem.
So just to confirm, for the second one, that 0 there can be like alpha or beta. As x tends towards 0, it can be as x tends towards alpha.
Yes.
And then, Miss Lentur, I just wanted to show or say something. You asked about tan x over x, ne?
Yes.
So the example right underneath that looks at an example like that. So they can change it to sine x over x over x. But then they try to get the sine x to look like the first theorem. But they don't try to make the cos x look like the first theorem because cos x isn't that's not what the theorem is holding for. It's only if you see sine x and you can get it over its angle. I don't know if that helps.
Okay. Okay. I think I understand the first two. But now there's something else because the second theorem, when I got it, I watched a YouTube video and I think I also saw it in my textbook. It said 1 minus cos x over x is equal to 0. And I see here it's cos x minus 1 over x is equal to 0.
Minus 1 plus cos x, ne? Is that what you
It's
said?
mine. No, the one that I have is 1 minus cos x
Over
x is equal
is
to
equal
0.
as x approaches 0 is equals to 0.
Yes, sir.
Ms. Lentor, that is the same as this. Minus 1 plus cos x over x as x approaches 0 equals to 0. Is that
No,
not
sir.
the same thing?
It's 1 minus cos x.
Oh, Ms. Lentor, I thought you said minus 1 plus cos x
No, sir.
is 1 minus cos x.
Is equal to 0.
That one, I can't see it on the same table with that one. That's why I'm saying to you, yes, with this, if there is a big present, I'm prepared to go with you. If you are using this. Anything beside this, I'm not part of that. Okay. Is it okay, my sister?
Yes, sir.
Listen to-
It's fine.
All right. Now, the question to that is 2 over 5, number 17. Ms. Lentur, I repeat. Is it clear to you?
Yes, sir. I understand now, sir.
Please ask your brother.
Seboho, do you understand?
I am losing connection here and there, but I imagine I'm all right. I just don't know. I tried to put the method I use in the chat there to illustrate how I went about my answer. But I did come to 2 or 5, and I feel I imagine I understand it. I imagine I understand it. I don't know if anybody can take maybe if it's correct, as opposed to
You are
me trying to
breaking.
explain.
Tebo, you're breaking.
I'm sorry. I don't know how to reduce. I need to reduce the. How do I do this?
Yeah, please talk to us about your problem so that we can be able to know how to help you. What is your problem?
So he sent a photo of
No,
his.
I came to.
Lorado?
He sent a photo of his
Lerato,
working
sorry,
out to the test.
I'm unable to see that photo.
So it's basically what we did, but what he did was he took the x minus 2, right?
Yes.
That we were trying to factorize and that we were trying to get in the denominator as well. And he did the same thing. He just, okay, let me read what he said. He said the limit of sine 2x minus 4 over 5x minus 10 as x tends towards 2. And then he said, let theta be equal to x minus 2. Then he said the limit of sine 2x minus 4 over 5x minus 10 as x tends towards 2 is equal, therefore, to the limit of sine 2 theta over 5 theta as theta tends towards 0. Or that's what
That
he was
is not
trying
me. That is someone else. Mine.
Oh, is that Andla?
Where
Sorry,
is
so that's
mine?
not. Oh, yours is
Yeah.
the one before that.
Mine is extremely blurry even.
But mine
my
was also
thing
similar
is
to what
just cutting.
you
I
did.
don't know. Yes. I need to reduce this so I can be clear. How do I do this? Okay, I
Members,
don't know if my is all right, but so I said I took the function and then I took x minus 2 as another function, and well, not as another function. I said as x minus 2, I mean as x approaches 2, x minus 2 approaches 0, and then I said let p equals x minus 2. So as x minus 2, as x approaches 2, p approaches 0. And then I used that, and then I substituted x with p, the x minus 2 with p. So as x minus 2 approaches, as x approaches 2, p approaches 0. So I used that. I used p approaches 0 as my limit, and then I said, where did I write this thing now? I know I wrote it here, not far away. Sorry. Okay, then I said sine 2 times x minus 2. So I factorized the inside, and then I factorized the denominator, taking out 5. And then I had sine 2p over 5p. And then am I audible?
Yes, we can hear
yes.
you.
Okay. Okay. And then from there, I just said, okay, I've got sine 2p, and then it is a double angle. So sine 2p is equals to 2 cos p sine p, and then all over 5p. And then I then factorized it and said sine p over p times 2 cos p over 5 is the factor of that. And then yes, as the sign of p as p approaches 0, is 1, and then it's 1 times 2 cos, where cos of 0 is 1, so it's 2 times 1 over 5 gave me 2 over 5, which I imagine is correct because it's the same answer as yours.
Members, can I make this request? Do you see this example 10.6?
Yes, sir.
Wait,
Yeah.
this is gonna my data, not my.
Do you see it?
Information.
Please, please go and do a search of different exercises related to this, so that you can be able to master questions related to this. This will enable you to can be able to master questions similar to question 17. Do you get me? Are you with me?
Yes,
Yes,
sir.
sir.
Sir, can I just add something? I went
Sorry?
through the sorry, sir. I went through the study guide and I saw that the limit of x approaches 0, cos x minus 1 over x is the same as 1 minus cos x over x. So both of them equal to 0.
Ms. Lentur, please repeat
Yes.
what you just said. I need to clearly capture that.
So, sir, I was asking earlier because I said my theorem, the one I got was 1 minus cos x over x as x approaches 0 is equal to 0. And the one that's saying on the screen was cos x minus x. over x as x approaches 0 equals to 0. So now I check in the study guide and it says that they are equal.
Yeah.
So I wanted to confirm in case I had the wrong answer.
Sorry?
I said I wanted to confirm in case I wrote down the wrong one.
Where is that? Okay. Do you see this, Miss Lentur? This.
Yes, sir.
Do you see this?
Yes, sir.
Do you see this?
Yes, sir.
Where is that? I'm looking for the second one. Where is it?
I think you just passed it, sir.
Did I pass it? Okay, let me
Yes, it is,
see.
sir.
Cos x minus 1 over x equals to 0 cos x.
Yes, yeah.
This one.
Yes, sir.
1 minus cos theta. The limit of 1 minus cos theta over theta. As theta approaches 0 equals to 0. 1 minus cos theta. 1. I see what you mean. Miss Lentur,
Yes, sir.
in this case, 1 is negative. In there, 1 is positive, and the cos is
Yes.
negative.
Yes, sir.
This one. I see what is confusing you now. So, okay. Let's stick to one thing. One thing, Ms. Lentur. What is your study guide saying? Is it taking this one?
It's saying that they are equal, sir. It's showing both.
Both of them.
Yes, it says the one you showed is equal to this one. So either one you get it is 0. And the same with the sine one, sir. So with sine x over x as x approaches 0 equals to 1. It also says x over sine x as x approaches 0 is equal to 1 as well.
Or he's saying this one is similar to this one.
Yes, sir.
And he's saying this one is similar to this one.
Yeah, they're the same, sir.
No. I just need to confirm what you just said.
The textbook says that x over sine x is x approaches 0 equals to 1 as well.
This is what we are also saying here. What is the problem?
There is no problem, sir. I just went to go check for cos, and then I saw that with sine, it was also like the same.
Oh, there is no problem.
Yes, so there's no problem.
Because these two, this one, this and this are saying the very same language, are talking the same language. Is that what you are saying?
Sir, I don't think you heard me.
I need to hear you.
The textbook that I just checked now, so the one that you got the study guide, it says that this here, the sine x over x equals to 1 is the same as x over sine. So the inverse of it is also equal to 1. As x approaches 0.
Okay. Somehow I hear you. I heard what you said, ne? I heard you, ne?
Yes, sir.
But may I humbly request this, Ms. Lindor? May I request that we stick to this?
Yes, sir.
Which is similar to this.
Yes, sir.
To avoid the confusion.
Yes, sir. I was just saying in case you see something similar.
I don't want to confuse you. Okay. Oh, okay. All right. Okay. Members? Hello. Hey, Miss Lindor.
Yes, sir.
Please. Now, please call your brother for me.
Tebogo. I said it's muted. Tebogo, are you still there?
Hi, sorry, I'm here.
Thank you, Ms. Lindor. Deborah? Thank you.
Doctor.
Yes. My brother. Please.
Yes, sir.
Please request the family members for me to say, I'm requesting us to stop here, okay? With an agreement that when we meet, we'll continue from here, and I will also go and look for those exercises related to squeeze theorem so that you can be comfortable in handling in exercises that are applying the squeeze theorem. That's my request from you.
Yes, sir. Family members, can we call it a night, and then probably just prepare ourselves for some material on tomorrow, or will we be released, or maybe there's somebody who sees otherwise, but are we saying we're good to call it a night for tonight?
Yes, I just have a question.
Yes.
Was I requesting to look into something? Hello?
Hello?
Yes, so there's a question. Because Mina.
So what were you asking us to look into?
At this point in time, I just requested the chairperson to ask you, so that to ask for your permission that we stop here, and then to request him to request you to stop here, so that next time when we meet, we'll continue from here, and then we'll also look at a number of exercises that are applying the squeeze theorem.
So, sorry, does this mean we're not coming back to this when you come back?
We're coming, Deborah. Sure.
Hey.
I'm saying we're stopping here. When we meet, we'll continue. After finishing these exercises. Remember, problem solver needed more exercises on the application of the squeeze theorem. Then we'll go and deal with a number of exercises related to the squeeze theorem before we move to continuity. which is our next section.
Okay. Okay. Mr. Shulmani Mandla has raised his hand, but I agree with you. I don't know if maybe because if maybe like somebody was not clear and then we leave the session. I don't know, but I'm asking if maybe have a chance to watch a young series before some of us to wind down, or
You're
I'm
breaking.
asking the family members, guys. Ish, just,
No,
don't know
no,
how
it's
to-
100%. I just wanted to ask when we're meeting again. That's all. Sorry for raising my hand if it was uncalled for. Yeah, but I wanted to ask when we're meeting again.
Don't worry. My boss sends
No
out the
problem with
schedule.
raising your hand, sir. I will send you an email. Who is it? Is it Shumani Mandla?
Yes, it was me. That's why I raised my hand. Yeah.
Please write your email. Write your my life email address on the chat. I will email you the schedule.
No. I receive your emails.
Oh, okay. We meet again Tuesday.
Okay, thank you.
Thank you, my
All right.
sister.
Okay,
members. Is anyone having anything that, if not said now, then you won't have a peaceful sleep? Anything that, if you leave it not attended to, that might disturb your peace tonight? Is there anything that you need us to deal with? Adivao, anything?
Yes, sir. No.
Anything? No.
No.
Anybody? No. Okay. Can we then please request my boss to release us? And before I ask my boss,
sir.
before I call my boss to come in, again, please, let's keep this spirit of participating, please. That is how we'll be able to learn from one another.
Thank you guys for attending. Thank you for participating.